All right. Hello, physics. This is the first video for Chapter 4, Forces. In this video, I'm going to be going through and I'm going to be mentioning some of our most important forces, just kind of an introduction, and giving you equations for them. Now, my camera is being weird. You'll see this here. When I stand facing the camera, it gets super bright and bleaches out everything behind me. But if I turn around so that my face is not towards the camera, it seems to fix. So it dims back down to where you can actually see everything that's going on. So I'm probably not going to be looking at the camera much in this video because of that issue. Not sure what's causing it. Haven't had this issue ever before. So hopefully on the videos that I record later, this won't be an issue anymore. I apologize. I know it's probably inconvenient and irritating, especially if you're watching this late in the evening. So I will try to get this fixed as soon as I can. Be aware, I'm recording 3 videos today, so this is probably going to be an issue in all 3 of them. So again, I apologize. So let's start off by talking about the most important forces for you to be able to identify. And I'll actually move over here for this. First one we've talked about a little bit before, and that's weight. Weight is actually the force of gravity. So the force of gravity is always going to be equal to the mass of the object, whose weight we're measuring, times the acceleration of gravity, little g. And we'll talk about more what this equation means later, but this is your force of gravity equation. The next one that you'll probably encounter is going to be the normal force. Actually, I want to wait on the normal force. We'll come back to the normal force later. Let's go ahead and talk about friction. So, friction, or F sub F, the way I do it, is equal to the normal force times the coefficient of friction. So this could be kinetic friction or static friction, and that's what determines this letter. So this is a mu, much like micro in our unit conversions. It's actually a Greek letter. It just looks like an M the way I'm writing it, so it's actually that. That's the proper way to write it, but I'm not taking the time it takes to do that all the time. So that is a mu there. So force of friction is defined as the normal force times the coefficient of friction. These are your 2 main forces that you're going to be working with. Now, there are a couple of others that I want to mention. The first one I'm going to put up here, we're not actually going to use it all in this unit, and that is the buoyancy force. Okay, the buoyancy force is, or F sub B for me, is defined as the weight of the displaced fluid. So buoyancy force is going to be the, okay, let's see if I can remember this. Yeah. It's weight of fluid, so it's mg, but we sub in the density equation to get rid of m. So it is the density of the fluid times the volume of the object. So this is an F, this is an O, times the acceleration of gravity. Now, this equation we will not be using until Unit 9. I wanted to go ahead and mention it because it's an important force, but it's not a force that we are going to actively be using in this unit. Now, the other 3 forces we need to talk about are the tension, which I will use Ft, the normal force, which is Fn, and applied force, which I will use Fa. Now, these are the letters, in case you were wondering, that the textbook tends to use for these. I use F subscript for all of these to help keep straight exactly what we're referring to. These 3 do not have an equation. They are not defined in the same way. So because of that, we can't always set these equal to the same equation. These depend on what is actually happening in our sum of forces. So you have to, in order to get equations for these, you have to write a sum of forces equation like we did for vector addition. So a couple of caveats I want to mention on some of these. Weight is always straight down. So if we have an object that's moving sideways down a slope, the weight is straight down. If it's moving horizontally, the weight is still straight down. Always. Okay, force of friction is always opposite the direction of attempted motion. Now, I want to put emphasis on the word attempted. Let's say that I'm standing on a hill, and you can't see this because of where I am. But let's say, here, I'll draw it. Let's say I'm standing on a hill. If no friction was present, I would be moving this way. So therefore, there must be a frictional force to oppose that up the hill. So friction is always opposite the direction of attempted motion if no motion is present, and opposite the direction of motion if motion is taking place. Buoyancy force is always straight up. And I didn't write down up here. Now, tension force is always going to be equal on both objects. So let's say we have these two objects that are connected by a string. Okay, we would call the force exerted by the string the tension force. And it is the same on both sides. So the tension can't be high over here and low over here. It must be the same. So here we would say that Ft1 acting in that direction. And here we would say that Ft2 is acting in this direction. But Ft1 has to be equal to Ft2. And this will become more apparent as we do some more practice problems later on. Specifically equilibrium problems. Normal force is always perpendicular to the surface of contact. So I'm going to use this symbol. This means perpendicular to surface of contact. And we've talked a little bit about this before. If I'm standing on the ground, then the normal force the ground exerts on me is straight up. But if we go back to that hill question, and I'm standing at an angle, and I have a friction force this way, my weight is straight down, and my normal force is perpendicular to the surface of contact. So this has to be a right angle. So this is another one. This does not become super important until after we get to tilted problems, but it's an important definition that you need to know. Okay, normal force is defined as the force of support, and it is always perpendicular to the surface of contact. I should add that. Support force. Okay, the last one is applied force. Now, this is just our general catch-all. This is a force that came from somewhere else. So, if I am pushing on a box to move it across the room, I'm exerting an applied force on it in order to get it to move. It's just our generic catch-all term that we use. Is we just call it an applied force whenever that becomes an issue. That is pretty much it for this video. This is the first one of 3, like I said. So there will be a couple more coming out. These should all be posted by the time you guys get up. So I'm going to go ahead and stop it here, and we'll go on to kinematics problems and merging kinematics and force problems next, and then after that we will do equilibrium problems. So, hope y'all are having a wonderful day, a wonderful morning, and I will talk to you in a bit.